could find. Quantum of Science is the name of this segment. Sustained high fidelity quantum teleportation has been achieved for the first time. Um, Quantum teleportation sounds cool. This does not mean Star Trek teleportation. It does not mean Star Trek The Next Generation style teleportation, but it more means the teleportation of information. And let's see, in Fermilab, which is in Illinois, published in PRX Quantum, a demonstration of sustained long distance 44 kilometers of fiber teleportation of qubits of photons with greater fidelity than 90%. The qubits were teleported to a fiber optic network, blah, 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 blah. And they got great results. So this is the furthest anything has been teleported and with the most accuracy, I believe. High performance and scalable quantum teleportation system. What this means, it does not necessarily mean we will be teleporting. It definitely does not mean we'll be teleporting anywhere soon. Maybe hundreds of years down the line, this could lead to some sort of teleportation device. For right now, what this means is a quantum internet. It's going to be the basis of a very secure internet. And what I mean by teleportation is something like this. Let's check out this. I have this abstract here that I read, and it's still, even if I, even if you know science, and I know a lot of science, it's really hard to wrap your mind around exactly what they're doing. Um, but let me read this description of what quantum teleportation is, using the familiar monikers Charlie, Bob, and Alice, which represent the letters A, B, and C, as a thought experiment to um, to get your head around what's happening here. Let's see. Okay, so Charlie has a polarization qubit. That means a bit of information, a quantum message. All that means is a, a message. This is just one bit of information, but as you know, a letter can be represented by 8 bits of information, uh, and computers use 32 and 64 bits of information to store data integers and long integers. Um, all we're talking about is a message. It could be a video. It could be Charlie's manifesto, and he has this information in the form of a an atom that's in a certain quantum state. Basically, he wants to get this exact atom from his house to Bob's house. But the problem is sending atoms or photons. I should say photons. These are photons. Sending, I believe, it's the piece of information that they're using is a photon in this example. Um, Sending that bit of information to Bob is dangerous because it could get lost along the way. It could get intercepted. Somebody else could grab the information, and then it's gone. And Bob doesn't have it, and some other evil person has it. But luckily, Charlie is located close to Alice, who has already shared a singlet state with Bob. That means Alice and Bob have Alice has made a quantum pair of uh, photons and sent one to Bob. Let's go to the drawing board for this. I'm going to try to sketch out a little bit of how quantum teleportation works for as far as I understand it. We have Charlie, we have Bob, we have Alice. Charlie has this, let's say, uh, this atomic bit of information that he wants to send to Bob, and he doesn't want it to get lost or stolen. So what he does is Alice has two little photons that are entangled, and she sends one to Bob and one to Charlie. Now this entangled photon, these two entangled photons have, oh, I didn't go to the drawing board. There we go. There's the drawing board I'm drawing on. Uh, these entangled photons uh, have the action at a distance property. But what that really means is they contain the same information. It's like a code. It's like Alice sent the same code to Charlie and to Bob. And now what Charlie does is entangles his data bit, qubit, with the entangled photon that Alice gave him and comes up with a new encoded a bit of atomic information here. And so what that means, that's like it's an encoded message. Now, Charlie, he still has his original message. He's not sending the original. He made a copy and he encoded it using the encoded photon. Now he sends the encoded copy over to Bob. So Bob has this encoded piece of data. And all Bob has to do now is untangle that encoded piece of data with the entangled photon that Alice sent him in the first place. Like I said, Alice sent him the code de, decoder. It's a decoder ring. Alice sent Bob a decoder ring, and she also sent it to Charlie. Charlie encoded the information and sent it to Bob. Now Bob has the encoded information and the decoder ring, and he decodes it and gets the original information. And bit of atomic, this 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 atom, unentangled qubit that Bob now has, is an exact copy of the one Charlie has. Now Charlie still has his, so it can't get lost. It didn't get lost along the way. And Bob now has an exact copy of that, which is what Charlie wanted. Charlie wanted to send Bob a copy of his data. Now Bob has the data. Now, the reason this is so great and secure is because if any evil demons, we'll say D, come in and uh, and grab one of these pieces of information in transit, uh, Bob will know because you can't take a photon, you can't read a photon and then keep sending it along. The demon can't read it and keep and send it along. If the demon reads it, it's done. The code is broken, and Bob will know that somebody intercepted it. And at that point, uh, Charlie can just send another copy. So if it gets lost in transit, it doesn't matter. They'll just send another encoded copy. If somebody picks it up on the way, they won't be able to decode it. Uh, Presumably, they won't have both the decoder ring and the encoded data. Uh, and if they did, Bob would know that somebody was decoding the data. And if they only have one piece or the other, there's nothing they can do with it, and Charlie can just send another one. So basically, what we're talking about here is a quantum internet where uh, you can send data securely. You can know for sure that your receiver has received it or not, and if someone in the middle has intercepted it, you will know, and you can just send another encoded copy. So that's real security in data transmission. Very exciting. Um, it, it's worth noting that this, if you're thinking about Star Trek teleportation, this could be a way to do it. what you would have to do is uh, you would have to scan someone's entire body or the object that you were going to teleport. Say it's one of these cute little toxic African rats. You're going to scan the rat, every single atom in the body, and in a database, you take every single atom down, its position and its state. Now that you know that information, you can securely send every single bit of that information over the wire to Bob. And on the other side, if Bob has a reassembler, uh, then presumably with that information, Bob can reassemble the rat exactly, knowing that if any information is missing, it can be resent. And uh, so it's more of a duplicator, actually, what I'm describing than a transporter. What a transporter would do is read the rat and then murder the rat, and then send the information to Bob, who would reconstruct the rat that would presumably uh, wake up on the other side and think it was the same rat that Charlie killed. Um, Same goes uh, for Commander Riker if he got sent. Uh, the teleporter really is a murder device that takes stock of every atom's every state, the state of every atom in one's body, murders them, and then sends the information securely to another reassembler that puts them back together. Are they the same person? I don't know. We'll have to see. I'll be the first one to jump in one of those though and check it out and see what it feels like. One more story on quantum internet. Quantum internet signals beamed between drones a kilometer apart. So same sort of deal. In Fermilab, they did this over 44 miles or kilometers of uh, fiber optic line, and this is the same thing done through the air by lasers between drones. So let's see. Entangled photons have been transported more than 1,000 kilometers in tests between a satellite and ground stations before. I didn't actually know that, so that's a very long amount of distance. Um, so a laser on board of one of the 35-kilogram drones created a pair of entangled photons by splitting a single photon with a crystal. One photon was sent directly to the ground station, and the other to a second drone a kilometer away. Same thing, Alice, Bob, Charlie, and this is just moving the information through the air instead of fiber optic line. So pretty cool. This, uh, could be the beginning of a new sort of secure Internet of Things where everything can sort of securely talk to each other. And that's Quantum of Science.